It is given the next information. This question asks you to explore cubic polynomials of the form x minus r multiplied by x squared minus 2ax plus a squared plus b squared for x is real, and corresponding cubic equations with one real root and two complex roots of the form z minus r multiplied by z squared minus 2az plus a squared plus b squared is 0 for z is a complex number. In parts a, b, c, let r be 1, a be 4, b be 1. Consider the equation z minus 1 multiplied by z squared minus 8z plus 17 is 0 for z is a complex number. And question AI, 1 mark, given that 1, 4 plus I are roots of the equation, write down the third root. We know that if a complex number is a root, a complex conjugate is also a root. How to find a complex conjugate? We just substitute negative I for I everywhere in the expression for a complex number, so 4 minus I is the third root. The next, 1 mark. Verify that the mean of the two complex roots is 4. To find mean, we need just add two numbers. It is needed complex roots only, so 4 plus I plus 4 minus I over 2 is 8 over 2 is 4 as required. The next, consider the function f of x is x minus 1 multiplied by x squared minus 8x plus 17, x is real. B, 4 marks, shows that the line y is x minus 1 is tangent to the curve y is f of x at a point A with coordinates 4, 3. So we need just find the equation of a tangent at point A. To find that, we need the gradient of a tangent, and to find that we need derivative of a function, because derivative at a point is equal to the gradient of a tangent. So derivative of f is, we can see a product, so applying a product rule, it becomes x minus 1 derivative, which is 1, multiplied by just x squared minus 8x plus 17 plus x minus 1 multiplied by the derivative of this, which is 2x minus 8, and simplify it, it becomes x squared minus 8x plus 17 plus 2x squared minus 2x minus 8x plus 8 is 3x squared minus 18x plus 25, and derivative at point 4 is equal to 3 times 16 minus 18 times 4 plus 25, and it is equal to 1. Hence, gradient of a tangent is 1, and equation of a tangent becomes 1x plus c. To find c, we substitute for 3 for x and y and get 3 is 4 plus c, c is negative 1, hence y is x minus 1 as required. And the next, c. Sketch the curve y is f of x and the tangent to the curve at point A, clearly showing where the tangent crosses the x-axis, 2 marks. So we need just plot a graph of this function and this tangent. You may use a calculator, and it looks like this. We can see that there is a real root x is 1, so it looks like this, and tangent, and we can see the tangent also passes through 1, 0, so its y is x minus 1, its function f of x, and its point A, 4, 3, so it's drawn. The next, consider the function g of x, which is x minus r x squared minus 2ax plus a squared plus b squared x is real, r, a, b are real, and b is positive. di shows that derivative of g is, and we need just find derivative of g. 2 marks. So again, product rule, it becomes x minus r derivative with respect to x is just 1 multiplied by x squared minus 2ax plus a squared plus b squared plus x minus r multiplied by the derivative of this. So it's 2x minus 2a, and it is equal to 2x minus r x minus a plus x squared minus 2ax plus a squared plus b squared as required. And the next, hence or otherwise prove that the tangent to the curve y is g of x at the point A with coordinates a and g of a intersects the x-axis at the point R with coordinates r, 0. So we need to find this point. So we need equation of a tangent, and we will need this y coordinate of point A. So let's find it. G of A is equal to a minus r, and a squared minus 2a squared plus a squared is 0 plus b squared, so it just multiplied by b squared. And derivative at point A is equal to a minus a is 0, so it's 0, a squared minus 2a squared plus a squared is 0, and it's just b squared, and it's gradient of a tangent. Hence, equation of a tangent becomes b squared x plus c. To find c, we substitute coordinates of a point A, so it becomes y coordinate a minus r. B squared is equal to b squared, and a is x coordinate plus c. A is b squared minus r, b squared is b squared a plus c, so c is minus r b squared. Hence y becomes b squared x minus r b squared, and we need x-intercept, so y is 0, and it's b squared x multiplied by x minus r. Since b is greater than 0, hence x minus r is 0, so x is r, and hence x-intercept is at r, at point R with coordinates r, 0 as required. The next, the equation z minus r z squared minus 2az plus a squared plus b squared is equal to 0. Z is a complex number, has roots r and a plus minus I b or bi, where r, a are real, b is also real, and b is greater than 0. And question E. 1 mark. Deduce from part di that the complex roots of the equation, this equation, can be expressed as a plus minus I root over g derivative at a. We need to show this. And you can see that this equation and it's the same expression as for this function g. So it is given to use d, to use the result from di. So this result, it's about derivative of g at x, and derivative of g at a is b squared. So we can see that complex roots are a plus minus bi, it is given, and b is a square root of g derivative at a. In general plus minus, but b is positive, so plus it's from this. And hence roots are a plus minus I root g derivative at a as required. And the next, it is given the next graph. Point A, 80, C1, C2, X, Y, point R, this coordinate is -2, 0, and it is given the next information. On the Cartesian plane, the point C1 with coordinates A root g derivative at a, and C2 a negative root g derivative at a represent the real and imaginary parts of the complex roots of the equation above. It means this equation, and it's the same as function g of the same form. And the following diagram shows a particular curve of the form y is x minus r x squared minus 2ax plus a squared plus 16, and the tangent to the curve at the point A with coordinates a80, the curve and the tangent both intersect the x-axis at the point R with coordinates -2, 0. The points C1 and C2 are also shown. And question Fi: use this diagram to determine the roots of the corresponding equation of the form z minus r, z squared minus 2az plus a squared plus 16 is 0. It's this, but for z is a complex number, 4 marks. So we can see that the first root is real, its axis r, so it's just x-intercept here, it's -2. It's -2, and other roots are two complex roots. They are shown here, and we can see that it's a plus minus root derivative of g at a, but derivative of g at a is b, and from the general form of the equation we can see that b squared is 16, and hence b is 4 because b is positive, so b is 4 here, and the roots are a plus minus 4i, and we need a. How to find a? We can do We can find it from tangent, and we can see that what is gradient over tangent. We know that gradient over tangent at point A is b squared. It's we can use expression for g because it's of the same form, so we can use the next that derivative at A is b squared is 16, so derivative at A is 16, and we know the derivative at a point it's gradient over tangent, so gradient over tangent is 16, and we can see, or we can find the gradient directly from the graph as rise over run, and also gradient over tangent is, we can see rise is 80 over run is a minus 2, a minus negative 2, so a plus 2, and hence a plus 2 is 80 over 16 is 5, so a is 3. So roots are 3 plus minus 4i and negative 2 are roots. And the next, FII, state the coordinates of C2, 1 mark. C2, we can see that it's just A, which is 3, negative root g derivative at A, it's B, so it's negative 4. The next, it is given that consider the curve y is x minus r, x squared minus 2ax plus a squared plus b squared. For a is not equal to r, b is positive, the point A with coordinates a, g, o, a, and r with coordinates r, 0, are as defined in part dii. So a is this point, r is this point, and the curve has a point of inflection at P. And question GI shows that x coordinate of P is 1/3 multiplied by 2a plus r. So we need to find point of inflection. We know that point of inflection, its second derivative is equal to 0. So since it's the function of the same form as g, we consider g again. And where is the first derivative of g? It's here. It's this one, 2x minus r x minus a, 2x minus r x minus a plus x squared minus 2ax plus a squared plus b squared. Let's check. X squared minus plus, yes, it's correct. So it's the first derivative of g. So find the second derivative, and it's a product. So again, product rule, 2 derivative of x minus r is just 1 multiplied by x minus a plus 2 x minus r multiplied by the derivative of x minus a, which is 1, plus 2x minus 2a, and to be a point of inflection it must be 0. We can divide each term by 2 and get x minus a plus x minus r plus x minus a is 0. 3x minus 2a minus r is 0, x is 2a plus r over 3. So it's point P, point of inflection, x coordinate, and it's as required, it's correct. And it's also given you are not required to demonstrate a change in concavity. And the next question, hence describe numerically the horizontal position of point P relative to the horizontal position of the points R and A. So point A is x coordinate is A, point R has x coordinate which is equal to R, and point of inflection is somewhere in between. So it looks like this: point R with x coordinate R, point A with x coordinate A, and somewhere point P with x coordinate x. And we need to find ratio in distances between distance between P and A, and distance between R and P. And we can see the distance PA is A minus x, and distance RP is x minus R. And actually there is formula how to divide some line segment in proportion. It may be used by, I don't remember this formula. And we can use this, and we can see that 2x minus 2a to make, because we have r with coefficient 1 in front, so we can consider this 2x and 2r, and plus x minus r is equal to 0. It's directly from this. Why we do this? Because if we factor out 2, we get x minus a plus x minus r is 0, and it's negative 2a minus x plus x minus r is 0, hence x minus r is 2a minus x. So what this question describe horizontal position of point P relative to horizontal positions of points R and A. And we can see the distance between x minus r, it's a distance between R and P, so distance between R and P is twice the distance between P and A. And the next, consider the special case where A is equal to R and B is positive, and HI. Sketch the curve y is x minus r, x squared minus 2ax plus a squared plus b squared, for a is equal to r is 1 and b is 2, so we can just substitute it and get x minus 1, x squared minus 2x plus 1 plus 2 squared plus 5. And you need just to plot graph of this function. You may just use a calculator, but what does it mean a is equal to r? It means that these 2 points coincide, and if you plot a graph, it looks like this. and we can see that x is 1 is a root, and it looks like this. One x y. And the next question, for a is r and b is positive, state in terms of r the coordinates of point P and A. And when A is r, you can see that this point is here, and also so A becomes just r 0, and P can be calculated directly from this, and A is r, so 3r over 3 is also r, and hence this point, for example, for this example, is also a point of inflection. So the last question, for a is r, state in terms of r the coordinates of points P and A. 1 mark. So A is it's actually the same point, r0, and actually you may write as 1 point because it's the same point. So A has coordinates r0 and P has coordinates also r and 0. And that's all for this question.